Hello, as regular viewers of the channel will know, I really like C++, and I use it for pretty much everything. But there's one thing I've not yet covered on the channel, and that's using C++ with graphical user interfaces, or GUIs for short. C++ and GUIs have a bit of a notorious reputation. For some, it's akin to vigorously applying a cheese grater to one's buttocks, and for others, it's like removing teeth with a chainsaw. For some reason, C++ and GUIs have just never really married together very well. In this video, I'm going to introduce the wxWidgets framework, which is quite a mature and sophisticated graphical user interface API that we can use to create graphical applications in C++. Now, I don't want to start some sort of internet flame war, and I am well aware that there are plenty of other frameworks for doing graphical user interfaces in C++, but I'm choosing wxWidgets because I've been using it for 15 years, it's mature and stable, and very customizable, though we won't go into the advanced customizations in this video. In fact, I'm really only going to scratch the surface of what we can do with C++ and GUIs, because getting the framework set up in the first place is often the largest hurdle to overcome. So let's get started.
In fact, let's start at the very beginning. Most of you will probably be quite familiar with graphical user interfaces, and some will argue that we've actually covered them all the time on the channel. After all, we show things on a screen and we interact with them. But what I'm specifically talking about are those things that you frequently see in your operating system. I don't mean things like console game engine or pixel game engine, I mean native applications such as this example one here, where you've got list boxes and text entry boxes, buttons to choose from, buttons to press, and indeed a window you can move around, close, maximize, minimize and resize. So I don't have to keep saying graphical user interfaces because it's a bit of a mouthful. You'll often hear me say GUI, G-U-I. Now, specific to Windows and C++, you've had some options for quite some time, but more recently it's become quite difficult to find a good combination of GUI development for a C++ environment. You've always got the Windows API, but this is a bit of a mouthful to use, it's quite deprecated and programs in an old style of C++. In fact, some may argue it's not C++ at all. 3 million years ago, Windows also introduced the Microsoft Foundation classes, which attempted to apply an object-oriented approach to graphical user interface development. Again, the remnants of this still exist, but on the whole, it's quite difficult to get up and running and use now. As the nature of Microsoft and the structure of Windows has matured, they now thrust upon us the idea of Universal Windows Platform, which is a complex framework of components to make your applications look modern and polished, and also be entirely compatible with the product range. On the whole, it's my belief that Microsoft have strayed away from allowing people to do C++ and graphical user interfaces, and have instead decided that people should try and use C#.
And I should say at this point that that's not the daftest of ideas. C# is really engineered towards producing graphical user interfaces using the WinForms framework, and it's actually quite a pleasant and rapid development approach. But I'm well aware there are just some of us that love C++ too much that that's the language we're going to stick with.
Now, I'm quite certain that all this mention of Windows and Microsoft has already caused half of you to stop watching, but what do you do if you also want to have a user interface in Linux? What are the options available to you? Well, Linux being Linux, I'm quite sure there are at least 20 million different options. Admittedly, it's been some time since I've had some familiarity with Linux, but I remember that GTK was always a popular graphical user interface development framework, because of course with Linux you can switch the frameworks at will. And the reason I bring Linux up is that there is no commonality between any of these technologies and any of these technologies. So, in the past, the programmer would have to create a completely unique application for a Windows platform and a completely unique application for a Linux platform, and possibly Mac and other platforms too, which is quite frustrating. Obviously, as a programmer, we want to do it once and have it work on all of the platforms, and there have been options for us to do this. So if we wanted to do a GUI application that works on Windows and Linux before, your options typically could involve something like Java. And Java runs in a virtual machine, so it's guaranteed to look and feel the same way on all of the different platforms. And I recently had a look into Java, and that's become a complete mess. And so wanting to stick with C++, and I know there are many frameworks out there, but the big two are certainly Qt and wxWidgets. These two technologies are more than just GUI frameworks. They're entire operating system platform frameworks, so they'll contain components to handle multi-threading across different systems, to handle file systems, to handle things like peripheral input, as well as just the look and feel of your applications. And both of these technologies do something quite cool. They use the native available components for those systems. And so if I write my application and use the wxWidgets framework, it in fact uses Windows controls on Windows systems and Linux or GTK controls on Linux systems, and whatever the equivalent is on Mac. I've never used a Mac. And this means that your application doesn't look out of place when it's run by the user on those systems. It's not 100% perfect, but it's not bad. And I know the choice of framework is quite divisive amongst the community, but today I'm going to look at the one I enjoy the most, wxWidgets, which will allow me to make a single application source that will provide a graphical user interface on different operating systems. I think before we get stuck into any code, it's important to understand the general structure of how a graphical user interface works. In all of my videos to date, I've taken the traditional program model, where we have a while loop, and fundamentally in that loop, we get the input from the user, we do some stuff, and then we update what the display displays. And this approach is called polling, where every iteration of the loop, we sample some input to see if anything has changed state, and if anything has changed state, then we act upon it by doing the appropriate stuff, and we may alter the things that we want to display. Now, from a computer systems perspective, all applications follow this model. But when working with GUIs, this process is abstracted away. It's hidden from the end user. So the programmer works with a different model. The GUI can be broken down into two major components: the structure and events. The structure defines what the GUI looks like. Fundamentally, a GUI consists of lots of little rectangles. So here we've got the window itself, which is a rectangle, and here we've got the buttons, and here we've got a list box, and here we've got a text box, and here we've got radio buttons, but in fact they're actually surrounded by little rectangles, and all of these little rectangles, unsurprisingly, are called windows, or panels depending on the approach that you're coming from. And indeed, the operating system and its libraries are tasked with supporting the upkeep of all of these windows. And so a GUI can be represented as a tree-like structure. We have our main form in the background. Now, form is one name. You may hear me call it a dialog, you may hear me call it a frame. Sometimes just a window, but it represents the overall bounding rectangle that is our application. And that form can act as the parent for lots of sub-windows. So we may have text boxes or buttons, and we can have more complicated structures, such as a list box, which has the scroll bar at the side. Now, that scroll bar itself could be a window, and the content of that list box could themselves be text boxes. This means we can construct a tree using a parent-child relationship. So windows have parents that are windows, and a parent can have many child windows. Events represent things that have happened in time. For example, when the user clicks this OK button, a whole sequence of events may have took place. But one of them in particular will want to call some function that we provide to suggest that the button has been clicked. So, on button clicked. Now, I'm deliberately simplifying things here, because, as I mentioned, there's actually quite a lot of events that have taken place. I've drawn in here the mouse cursor. As the mouse was moved over the button, we actually got a on mouse entry event. Whilst the mouse is moving across the button, we're getting on mouse moving events. As the user presses the left button to start the click, we may get something like on mouse button down. When the click has finished, i.e. the user has lifted his finger off the button, we might get the opposite, on mouse button up. And as the mouse exits from the button's rectangular area, we may get something like on mouse leave. So fundamentally, there are lots and lots of events happening across our application all the time. And we as programmers don't want to have to deal with every single one. Sometimes it's useful to pick one out and work with it, but working with all of these all of the time is very frustrating. So a good GUI framework will be able to look at all of these events and work out what sequence of actions and timing has occurred to generate a more general event which is useful to us, the fact that the button has been clicked. And therefore, when we're developing GUIs, after we've declared what the structure of the GUI should look like, we then populate some code with what are called event handlers. And these are specific to the functionality we want to provide in our application.
But, and this is quite important, fundamentally we're getting away from this idea of sitting in a while loop. Instead, what we're doing is providing little nuggets of code which can be called at any time, in any order, quite unpredictably. And so this is quite a shift of thinking for the programmer.
As I've already mentioned, the framework I'm going to use is wxWidgets, and you can get it from wxWidgets.org. I'm not going to argue whether it's better or worse than other frameworks. I'm just going to show in this video how we can set this framework up and start using it to generate some applications. It's very mature and actively developed by a strong community. And to get it, just go to the webpage wxWidgets.org and click the Download Now button. This will take you to the Downloads page. Now, there are some other languages that wxWidgets supports, but we're interested in the C++ version, which is its major version. And I'm going to download the source code, because I'm going to compile it myself and install the SDK that way. And I'll get it by clicking the Windows Zip download link here. And it's about 30 megabytes. Just before I move away from the browser, wxWidgets also comes with an extensive amount of documentation and many components. So here is a complete class list. Let me just zoom in slightly so you can see some of these. A complete class list of every type of component that wxWidgets provides. There are hundreds of them. So let's just pick a basic one, something which you'll use a lot, which is button. There it is. So a button is the thing that you click in order to do something. And the documentation is very nice, so they've got an inheritance diagram to show where it lives within the framework. And if you're not completely familiar with object-oriented programming, don't worry too much. Typically, the methods are exposed that you need, and the way that you interact with these objects is quite intuitive. But it does go on to give you quite a detailed description of how to use the component and all of its parameters. Oh, very nice. It also shows how the button will look on the different platforms. So here we've got the Windows experience, here we've got a GTK on Linux experience, and here we've got a Mac experience. And that's because wxWidgets has used fundamentally the native components for that operating system, i.e., unlike Java, it isn't drawing the buttons in a particular way. There's also a lot of examples on how to use wxWidgets as part of the documentation package, and as I said before, it's not just a graphical user interface framework, it can handle all sorts of things for the operating system too. It even has links for OpenGL applications, using the ribbon parts of the user interface, and printing stuff for those that still print things. Now that the download is finished, I'm going to go to my SDKs folder on my hard drive, which is where I install all these sort of things, and create a folder for it. And it was wxWidgets version 3.1.2. And as you can see, I've got several previous versions of wxWidgets for other applications I've been developing. The zip file we downloaded contains quite a lot of stuff. I'm just going to grab all of that from the zip file and copy it into my new folder. Right, that took far too long, but there's a lot of files for it to copy over. Now, I said we were going to build wxWidgets from source. And the wxWidgets developers have made this very easy too. Go to the Build folder, go to MSW, Microsoft Windows, and here you've got lots of different Visual Studio solutions for all of the different versions of Visual Studio. The most recent one that they're supporting in this download is Visual Studio 15. I'm currently running 17, but that shouldn't be a problem. It will pop up a little warning, because now Visual Studio is concerned with security, and you don't want to just be compiling any old code that you're not familiar with and running with it, of course, so I'm going to say it's okay to open this. I trust the provider of this library. In the Solution Explorer at the side, we've got all of the major components of wxWidgets. And this is very important. Don't do anything other than this at this point. Go to Build, select Batch Build, and it will list all of the different build configurations that this project provides. Now, wxWidgets is quite unique in the fact that it'll allow you to build things in a DLL fashion or a static library fashion. If you're just starting out with graphical user interface programming, don't worry about it. All I want you to do is select all and then click Build. But before you click Build, and this is really important, go and make yourself a cup of coffee. As depending on the capabilities of your computer, this can take up to 20 minutes. Don't worry too much if you see any warnings or errors. There are actually very few, and if everything goes to plan, you won't see anything at all. but just let it do its thing and drink your coffee.
Whenever I'm compiling something massive like this, it always makes me feel a little bit of sympathy towards those that work on projects that contain thousands of files. Compile times become a real issue. As casual hobbyist coders, which I believe most of the viewers of this channel are, we take it for granted that we can just click compile and within under 2 or 3 seconds our application is already up and running. But this is the reality for programmers all over the world, is that they need to really sophisticatedly compile their code and configure their build environments in such a way as to make this job less laborious. And that in itself can be quite a challenging task. Naturally, on Linux you wouldn't do it this way. Depending on the vendor of your Linux distribution, there are a variety of different ways to install it, and the wxWidgets website actually provides good instructions on how to do this. The one thing I will say is, if you do download it for Linux and you're compiling from sources, you will still need to sit through it compiling, but it does actually happen a little bit quicker than it does on Windows. Things I sit through for this channel.
And so after a nice cup of coffee, we should see that all of the projects have succeeded and that none of them have failed. If, however, you have experienced any that have failed for whatever reason, a good way to overcome that is to just go to Build and Batch Build again. Don't click Clean or anything, just click Build. It's typically because something was built out of order or there was a problem with one of the tools and some dependencies got messed up. So just click Build again and you should be okay. Once that's built, close down Visual Studio. You're done. You have built the SDK from source. And what it will have done is have populated the lib folder from our original SDK installation directory. So now we've got DLL versions and static library versions of everything that wxWidgets needs. Before we can start developing, we've got one last step we need to do. And that is we want to add an environment variable for wxWidgets. So I'm just going to go and edit that now. So we'll go to the Systems, Environment Variables, click the Environment Variable button, and I want to add a new system variable, and I'm going to call it wxWin, and the value is just going to be the path to the folder where we've installed it. So eDrive, SDKs, wx312. And that's just to make life a little bit easier in Visual Studio. Click OK, and we're done. Now, in a freshly opened Visual Studio, I'm going to go to File, New, and select Project. And most of you are expecting me to go, we click on Windows No, we don't. You see, no, this is different this time. We go to Windows Desktop Application, and that's quite an important distinction because we're making a program which is going to have to be very compliant with the operating system. Our program will merely be a guest in the operating system, far more so than it has been in previous videos. And I'm going to call mine Video wxWidgets. And click OK. Now, as is normal with Visual Studio, it will go ahead and create something for you already. And this is actually the WinAppy way of creating a graphical user interface. And the code already looks quite messy. In fact, the code that it provides, we can compile it and run it, simply creates a window with an about box. But it's looking at this is where we can see that there is a bit of a reputation with C++ and GUIs. So this isn't using wxWidgets, this is using the native Windows way of doing things. And it's a mess. So what I'm going to do is delete all of the files associated with this project. Now I know some of you in the comments will say, well, you could have created an empty project in the first place. Well, I'm just doing it this way. I'm going to select delete and remove all of those. Don't want any of them. Bye bye. And what I'm going to do now is set up my build environment to use wxWidgets. Firstly, I'm going to add a class, and I'm going to call this class CApp. Then I'm going to right-click on the project and go into the properties. And I want to make sure that I'm setting the properties for all configurations. Firstly, for C++, I'm going to disable the use of precompiled headers. I don't use them.
although ironically that would reduce the build time for really large projects that I was alluding to earlier.
We need to tell the compiler where to look for certain files. So in the General tab under the C++ settings, I need to tell it where it can find the header files. Now this is made easier because we created an environment variable, wxWin, which is pointing to the base directory of the folder, /include. There's actually two locations I need to add. The second one is also in a similar place, wxWin /include /msvc, and that's what's making it specific for compiling with the Microsoft library of tools. Then I want to go to the linker options and tell it where to look for the libraries themselves. Now today I'm just going to use the static library configuration of wxWidgets. I don't want this video to be a discussion between the virtues of static libraries versus dynamic libraries. And again, using our environment variable wxWin /lib/vclib. Click Apply. Now that's applied to both debug and release configurations, assuming we're running a 32-bit application. At last, we're now ready to start coding a wxWidgets application. One thing you might have noticed already is we don't have an int main. And this is what I was trying to indicate at the start, so you have to think a little bit differently. The framework itself is going to mask the int main and the fundamental program loop for us. Our entry point as a programmer is really just a starting class that represents what our application is. In many ways, this is not dissimilar to the Pixel game engine. But firstly, let's include wxWidgets. And I want to inherit from a base class provided by the framework, wxApp. Our application class needs to implement one function, which is onInit. So let's give that some implementation, and we'll just get it to return true for now. Even though we've inherited from the base class wxApp, we still need to tell the application where the entry point of our program is. For example, if I click to compile it now, we see unresolved external symbol winMain. Now, winMain is like int main for a regular C++ app, but it's specific to being an operating system compliant application. So we need to go and tell wxWidgets to go and generate main for us, and we do that by using this macro wximplementApp in one of our CPP files. The most convenient place is the application file, of course. Our app class isn't actually going to show anything, it's just really to get us started and get us up and running with a graphical user interface. So I'm going to add another class, main. Again, I'm going to include wxWidgets. And this main class is going to be a graphical user interface component. It's going to be a form, which in wxWidgets speak is called a frame. If we go to the implementation of the main class, because we're overriding wxFrame, we can provide some arguments to its constructor. And we'll see there's quite a few to choose from. So because this is our base window for our application, it doesn't have a parent. So I'm going to specify null pointer for its parent. All windows within the wxWidgets framework require an ID, but it's not always necessary to actually give a specific one. You can use wxID any to say, look, I don't care, just give it something. And let's give our window a title. OneLoneCoder.com wxWidgets. And so that's enough to override the constructor of the frame base class. Let's just compile and see if everything comes together. App has compiled, main has compiled, generating some code, and success. So let's just have a quick recap before we run this. We've created one class which is like the launcher for our application, and we've created another class which is the start of our graphical user interface. So it's here where we're going to define the structure and implementation of our event handlers. One last thing to do is to tell our launcher to actually display the window. So in my app class, I'm going to add a private variable, cMain, frame1. I'll have to include main, of course. And in the onInit function of our application, I'm going to create a new instance of main, and I'm going to show it, because main is a window. Let's take a look. And there we go, it's compiled, and it's produced a little window, and this window is resizable, and it's got minimize and maximize buttons. It behaves just like a window should. It's also got the title that we specified, OneLoneCoder.com wxWidgets. And so already, even though it's taken a little bit of time to get here, the code is far simpler to implement a windowed application, like the one we saw the Visual Studio environment had generated for us automatically.
Now, I'm only really going to scratch the surface of what we're capable of doing here. I'm going to add some very simple components to my form. It helps that I have some familiarity with what components are available to me throughout the wxWidgets framework, so it will be necessary to actually look at some of the documentation before you can dive straight in. However, you can often make an educated guess about what things will be called.
Before that, however, and to make the video a little easier to film, I want my window to appear in the same place each time. So I'm going to tell it to give it a top left corner of 30 by 30 and to give it a width of, well, we'll say 800 by 600 for now. Let's just see if that makes sense. Yep, good, so it makes the dialogue just a bit easier for us to see. Don't forget, there is a parent-child relationship between components and windows. So I'm going to add some components now. We'll have a button, a text box, and a list box. I'm going to create these in the constructor of my main class. Firstly, for the button, we want to tell it the owner, which of course is this, because the parent of the button is going to be the window. Not too bothered about the ID again. And the next argument is the label that the button will take on. So I'm going to have click me. And I want my button to appear 10 pixels in by 10 pixels down. Now, those 10 pixels are not relative to the screen, they're relative to the top left corner of the window of the parent. I'll also give it a size. Let's have 150 pixels wide by 50 pixels high. In a similar way, I'll now construct the text box and the list box. Let's just see what that looks like. Well, I'm not going to win any awards for graphical design, but we can see we've got a button with click me, we've got a text box where we can enter text, and we've got a list box, but there's nothing in the list box yet, so there's nothing for it to display. What I want to achieve is that when we click the click me button, it adds whatever text is in the text box to the list box. And to do that, we need to handle events. We want to be sensitive to when the button has been clicked. Fundamentally, my parent window is responsible for distributing the events. And wxWidgets provides tools to handle events for us. You just need to include them in your class by using this macro, declare event table. Now, all events in wxWidgets, if they're not custom, have a type, and when you click a button, the type is a wx command event, i.e. the do something event. So I'm going to create a function called onButtonClicked, which takes an argument, wx command event, evt. In the implementation of main, I'm going to go and create a body for this function. However, nothing yet associates this button being clicked with this function. We need to tell wxWidgets to do that binding for us. And there's a couple of ways we can do this, but I'm going to take the simple way, which is again using some macros in the background in the implementation of our class. We're going to implement what the event table is. So begin event table takes the name of the class that it is producing the events for, and it also requires the base class. In this event table, I want to be sensitive to a button being pressed. So there's a macro called evtButton, which is going to take the Windows ID of that button. I'm going to say it's 10,001 for now, and link any buttons with that ID being clicked to the function that we want to call. When we created the button, we specified that we didn't care about the ID, but now we do, so let's make sure that they're the same. Hopefully now when we click the button, the system will go ahead and call our onButtonClicked function. And all I want to do is add to our list box the contents of the text box. So I'll interrogate some of the member variables of the list box. Fortunately, we have one called appendString, which is going to add a string to the list box. And fortunately, I can get the string from the text box. GetValue. Now, wxWidgets uses its own string type called wxString. And this is actually very analogous to the standard library stdstring. You can use the two interchangeably. Once I've handled the event, I need to tell the system that this event has been handled. And we can do that by telling the event that it is finished by calling the skip function. Let's see what happens. So I'm going to add some text to my text box. I'm going to click the button click me, and we can see hello has appeared in the list box. In fact, I can repeatedly click and add lots of hellos. Let's add some other texts as well. And the nice thing about the graphical user interface is it handles all of these corner cases for us. We've not had to program the scrolling, we've not had to program the selection mechanism or the ordering of the list. Let's add something else, click me. Something which, if we had to code ourselves, would take an awfully long time. So why did we need to tell the system that we had finished with the event? Well, in this artificial scenario here, let's assume I click the OK button. The framework has deduced that the user has clicked with the mouse in a specific location. It just happens to be within this OK button for now. So the first thing it will do is call the onButtonClicked function of the OK button. But let's say for some reason I didn't care that this button had been clicked. I didn't use up the event by calling the skip function. The system then still has an event that needs resolving. Perhaps the window behind it cares that it has been clicked. So in this unusual situation, let's say I don't care that the button has been clicked. The system will then look at the parent window in that location, and if it has one, we'll call an onClick function. And it will do this all the way back up the tree that represents the structure of the GUI until something handles the event, or nothing handles the event. By calling the skip function on the event in wxWidgets, I've told it that it can skip checking all of the parents. The event has been handled, it's finished, it's done. wxWidgets has a little quirk regarding use of the new operator. Typically, if we've allocated something with new, we should also have a corresponding delete. But because of the unpredictable nature of graphical user interfaces, wxWidgets itself would rather maintain the deletion of objects. And in fact down here we can see from the last run of the program there hasn't been any complaints of memory leaks, even though I've not explicitly deleted the objects I've created. And this is for quite an important but hidden reason. As I'm interacting with the application, I'm generating many events. These events get added to a queue and are processed in a first-in, first-out fashion. The events, of course, contain information relating to certain objects, and it could well be that we have deleted some parent object whilst we've still got events that reference child objects in that event queue. To stop the application from fatally crashing when it tries to call the function on an object that has been deleted, wxWidgets will effectively postpone the deletion of the objects until it is sure that it is safe to do so. And I'm sure this is just one of the many arguments why C++ and graphical user interfaces just never seem to get along. Our application is not very dynamic. I can resize the window, but you can see nothing actually changes regarding the component layout. And there's nothing intrinsically wrong with this. We've, after all, specified precisely where everything should be in the window. But it's not very adaptable for different display and screen sizes. The way that we've implemented this particular dialog is also very rigid. It will only ever contain a button, a text box and a list box, and again there's nothing wrong with that. Many dialogues exist to serve one particular purpose. But what if we wanted everything to be a little bit more dynamic? What if we wanted to construct GUI components programmatically, depending on the needs of the application? For example, what if I wanted a 10 by 10 grid of buttons? Well, let's delete what we've got here, and we'll do exactly that. I'm going to create two variables, field width and field height, and have an array of pointers to buttons. And I will just clean up our event handler and our constructor. In the constructor, I want to create and populate my array of buttons. So I've created a new array here, which will be 10 by 10. That's 100 buttons, and I don't want to sit and program all of the code for 100 buttons. I also don't want to personally position them all over the place. I want them to be in a grid, and I want them to adapt to the size of the parent frame underneath. In the previous example, we rigidly positioned our button by giving it a top left coordinate relative to the parent and some dimensions to indicate its size. I can do something more advanced. I can defer to wxWidgets to automatically place the components for me by using what's called a sizer. And this is quite a cross-platform concept, so lots of other GUI frameworks will also have a similar construct. Sizers describe the relationship between a parent window and all of its children. So for example, I could have a sizer which breaks up the parent into nothing but vertical arranged components. So every time I add a new button, the button will occupy a particular slot in the sizer. And as we resize the parent window, the sizer gets updated and the sizer updates the size of all of its children. I want to position my buttons in a matrix. So I'm going to use something called a grid sizer, which ensures that all of the columns and rows of the children components are equally spaced. So as I add buttons, they get added in a matrix-like fashion. The sizer itself is not a GUI component, it's just a structure that describes this relationship. So after I've allocated the array for my buttons, I'm going to create a grid sizer and tell it how many rows and columns I want. I can also indicate the padding inside the rows and columns. Then, with a pair of nested for loops, I'm going to create my buttons and add them to my parent window. Now, in almost every one-learn coder video, we've always had y times width plus x to turn our 2D coordinate system into a 1D system for the array of buttons. So in this instance, I'm going to create a new button. The parent is still the frame, the window, it's not the sizer. I'm going to give it a unique ID based on its position within the array. And my newly created button is going to be also added to a sizer, the grid sizer. And these parameters are saying, please occupy the entire space of the cell in the grid and expand as necessary to follow the constraining dimensions imposed by the grid sizer. It's a little bit complicated, but once you see it in practice, you'll see precisely what I mean. Once I've constructed my buttons, I then need to tell the parent window which sizer to use. In this case, it's the grid sizer. And I'm also going to tell it to go and restructure itself depending on the information it's got. So it knows now it's got lots of buttons, it knows it's got to be 10 rows and 10 columns, and it knows the dimensions of its parent. So let's take a look. And we can see now we've got 10 by 10 buttons on our window. And if I change the size of our window, all of the buttons change size too. You may notice, and it might not be that visible on the YouTube video, that as I slowly scroll, we can see that the window actually extends beyond the 10 by 10 buttons, and then they all snap into place. And that's because the sizer is constrained to ensure that all of the buttons are exactly the same width and height. This means there is only a solution periodically where this is valid. This is another example of relying on the framework to just handle the corner cases for us. So there we've got 100 buttons, and they're all individually clickable. Now the eagle-eyed amongst you will have noticed down here I've got a memory leak. That's not because I've not deleted the buttons or the sizer, but I've not deleted the array of the buttons. So I'm going to add that to my destructor. Now I want to handle one of these buttons being pressed, and I want to handle them all in a fairly similar way. I could go back to my event table and now create 100 different entries, but that seems a little tedious. Instead, what I'm going to do is dynamically associate an event handling function with a button being clicked. And we can do that in our nested for loops. So I take the button and I call the bind function, which will bind an event handler to this particular event that I've specified as an argument. The button being clicked, so if the button is clicked, please bind that event to this function on button clicked, which is what we've got below. So I'm binding all of my buttons to the same function in this instance. And since I specified a unique ID for all of my buttons, I can work out which particular one was clicked and its x and y coordinates with some simple maths.
We like to do games on this channel, and since we've got an array of 10 by 10 buttons, let's make Minesweeper.
I'm going to assume that you're very familiar with what Minesweeper is. It's a small game where you click on the buttons and it reveals how many mines are in the surrounding cells. And you can use logic and a little bit of luck to deduce which buttons are safe to press and which ones aren't. So to store the status of the mines, I'm going to create another array of integers which is going to represent whether the mine exists there or not. I'm also creating a Boolean flag called firstClick, because I want to be sensitive to the first button being pressed. That's when I'm going to populate my minefield, to give the user a chance, or else, they could click it and immediately it's game over. After creating my array of buttons, I'm also going to create my array of mines. It's going to be the same size, of course. And in my nested for loops, I'm also going to set the default value for each location in my minefield array. I'm just going to set it to 0. The only time anything happens is when the user clicks a button. On the very first click of the game, that's when we want to generate the minefield. I'm going to assume that for a 10 by 10 minefield, that 30 mines should provide a sufficient challenge. I'm now just going to create a loop and randomly generate X and Y locations within that mine field, and if there is no mine at that location, I'm going to place one. So I'll just check that those values don't already exist where there is a mine, and I'm also going to check that the randomly selected location is not the same as the location of the button within the array. Again, we don't want the very first button click to cause a game over. So if this location is valid, I'm going to put a mine there. I'm going to set it to -1. -1 indicates the presence of a mine. After the first click, I'm going to set my first click flag to false, because we don't want to generate the minefield each and every time. Before anything else, I want to also disable this button from being pressed again. We've already tried it. Now, all windows have an enable function, and that stops any further user interaction with that particular object. The user has clicked the button, they could have hit a mine. So we'll check for that by seeing if that particular cell contains a -1. If it does, that's game over, and I'm going to call from the framework the wxMessageBox function with a message to say, well, the game is over. I then also want to reset the game. And resetting the game is quite simple. I set my first click flag back to true, and I go through all of the mines and buttons and reset them effectively. I enable them again, and I set the label to blank. So the label is the text that appears on the button. And I'm going to use that label to indicate to the player how many mines are surrounding the location they've just clicked. So if the player clicked and didn't hit a mine, we want to go through all of our neighbours and count the number of mines that exist. And I do this by having a very small nested for loop here, which is just going to iterate around the 8 neighbours of the cell that we've clicked on. And if any of those are equal to -1, then we keep a count of how many mines surround the cell that has been clicked. And if the mine count is not equal to 0, there must be some mines. So I'm going to use the setLabel function of our button to display how many mines were in the surrounding cells. And that's it. Not very many lines of code, but that's the gameplay for Minesweeper. Let's check it out. Here is my matrix of buttons, and I'm going to click one of them. And it's put a 1 as the label, so one of my surrounding cells contains a mine. So it's a bit of a guess, a bit of luck required. That's told me that 2 of my surrounding cells contain a mine. So there's a good chance one of these 2 is a mine. Let's see how lucky we can get. So 3 of these cells contains a mine. Oh dear. Well, I hit the mine, game over, and it should reset, and it has done. The text on the buttons isn't particularly clear, so let's change the size of the font to make it more visible. The wxWidgets framework makes this very simple for us. I'm going to create an instance of wxFont and tell it I want the size 24, and I can specify things like whether it's italicized, underlined, or bold, or whatever. And then for every single button, I'm going to set the font to that instance. And that's it. Let's see if that makes it look any better. So here is my array. I'll click, yes, there's a nice big 1. So one of these is a mine. That one's not a mine, and that's telling me that none of my surrounding cells are mines. So is this one. However, these 3 have to be mines because of this 3 here. And this one has to be a mine. And if those 3 are mines, and this cell has 2 mines, that one can't be a mine, so that one's safe. It's a nice game, this. I like this a lot. So all 3 of those are mines, so that can't be a mine, and they can't be mines. That can't be a mine, that can't be a mine. Oh, it gets very addictive. I could play this all day. Anyway, so this one must be a mine. Boom, there we go.
And so there you have it. I've only really scratched the surface of what you can do with graphical user interface applications and C++, and in particular I've looked at the wxWidgets framework to help me with this. It really does simplify things from having to do it yourself using the native operating system libraries. I've also only looked at the most basic and trivial of controls and events. There are probably combined thousands of different combinations, which as a programmer you need to choose the most sensible ones to suit your application. I'll probably follow this video up with a more advanced graphical user interface component video, where we look at making our own graphical user interface components. As it's often the case that you do need something a little bit more specific to express a particular set of information in a certain way that the native operating system can't provide. And for the Linux viewers out there, I know this has looked tremendously Windowsy, but bear in mind this will be completely compatible code for code with a Linux compiling environment too. I'll put these source files on the GitHub, but they won't work in isolation. You will need to download and install the wxWidgets framework to get them to do anything useful. Now I know this video has been very introductory and it's been probably a little bit fast and has skirted over some of the details, but the best way to learn about these things is just to get stuck in and give it a go. But if you've enjoyed it, please give me a big thumbs up, have a think about subscribing, and I'll see you next time. Take care.